Welcome. Good afternoon. The compiler design. Let us going to discuss. In this unit, we are going to discuss about the compilation and interpretation process. So here, first part of the compilation, the source code we are giving input to the compiler or interpreter. So it translates to target code or called as a mission code. The compiler translates the complete the source code to target code. Similarly, interpreter also translator to translate one line at a time to object code, and it got to execute immediately. So this is what's the difference between compiler and the interpreter. So compiler is a source code to machine code translator. Interpreter is a line by line compiler. Pre-analysis of the syntax analysis, specifying from the programming language. The source code are giving input to the compiler. So the syntax analysis, what this means, the source code will be separated into meaningful tokens. The tokens may be a regular expression. So it will be accepted by finite automata. So syntax tree will be constructed from the next phase of the compiler. So the source code into target code, between these 6 phases of process are going on. The first phase of is called the lexical analysis, or maybe called as semantic analysis or syntax analysis. So lexical is the first phase, syntax analysis is the second phase. Become syntax analysis, receiving tokens from the lexical analysis on generative tree. The compilation basis, lexical analysis is called scanner, and we call it scanner also. So this is the source for getting input to the lexical analyzer. The lexical analyzer operates into meaningful tokens. These meaningful tokens are entered next phase of the compiler, which is called parser, or we call as a syntax analysis. This producing syntax tree. This syntax tree giving input to the semantic analysis. This will be check the meaningful whether they have all the operators and operators having right rights data types is there or not will be checked by the semantic analysis. So this semantic analysis will be go for the machine independent code improvement, which is called as an intermediate code generator. It's optional. So this intermediate code generator going to this. Okay. So now we are going for the target code. The target code is last phase of the compiler, which produces a machine code. Without that, anything possible to minimize or optimize means automation compiler will be there. Optimization phase will be there. So it's how much as possible to minimize the program without changing the meaning of the program. So space will be reduced. So execution time will be reduced. All these are done by the third code improvement, which is called optimization of the compiler. Syntax analysis. Syntax analysis or definition, the way in which linguistic elements are put together from the construction. So all the meaningful elements will be put together and making it tree. The syntax of the programming language describes organization of tokens. Context-free grammars. The syntax on which used programming language is context-free grammar. Must be recognizable by compiler and interpreter, which is called parsing. So this is called LLR parser, LL parser, LL parser and LR parser. The context-free grammar add recursion to regular expression, mystery construction will be there. Like this production should be there, all the production should be repeatedly, which is matching to our production word, the repeatedly the production will be applied. So we recalled the context-free grammar, we called as a terminal symbol, non-term symbol reproduction. That context-free grammar is a combination of terminal, non-terminal, and the production rules. Production rules is nothing but the also out there syntax for the grammar. Parsing an arbitrary context-free grammar. Order of entry, too slow for the large programs. It takes entry of times means it is very slow, too large time it takes to compile. So linear time parsing. Linear time parsing is called as a LL parser. LL parser means left to right, leftmost derivation. L and L, leftmost derivation. Recognize LL grammar. Use a top-down strategy. LR parser. A left to right, rightmost derivation. Use for the LR grammar. Use a bottom-up strategy. It is a top-down strategy. It is a bottom-up strategy. LL parser is a top-down strategy. LR parser is a bottom-up strategy. The parsing example. These are the context-free grammar. Parsing for the A, B, C. Let us see that how the tokens are passing in the parser. Top-down derivation. A, B, C. These are the productions, context-free grammar. ID, ID list style. So ID list style will be behind, ID, ID list style. Okay, ID list style contains semicolon. This is the grammar. This is sentence which you want to generate. ID list will be separated as a ID list given two productions, ID and ID tail. ID will be taken as a ID tail will be there. Again, ID tail will be expanded. So ID tail will be expanded like this. So ID tail will be extended, another ID is B. So followed by third ID. Third ID is ID A, ID list. ID A, ID list, ID B, ID list. Similarly, this semicolon and comma will be so left to right. Topmost derivation, which is called as a top to bottom, which is called as a LL of one parsing. Top down derivations. So similarly, so ID list first identifier is A, ID list with the second identifier is comma, the followed by third identifier ID B, ID list again third semicolon comma will be there. So followed by ID C, and finally ID list will be semicolon. So this is a syntax tree which is constructed by the context free grammar. Bottom of parsing. No more.